So now we're on to topic 2, and we're going to multiply polynomials. We've added and subtracted. Now we're going to multiply polynomials. So you're going to open up your book to page 141. And 7.2 practice is posted in Schoology. Check in Schoology to see when that is due. So the first one we're going to look at is that we're going to actually start not on the first page in your book, but on the second one. And we're going to multiply each product because I think you actually kind of know what's happening here. So look at this carefully. What does this look like? That's right, it looks like distributive property, and that's what we're going to do. We're going to take negative 2x squared times x squared, and we're going to take negative 2x times 3x. Okay, so we're just going to distribute, but now we get to add in our rules about what we know with exponents. Okay, so let's go over that. When we multiply exponents, what do we do with our, when we multiply like bases, what do we do with our exponents? That's right, we add, so that's what's going to happen. So negative 2x squared times x squared is going to give us a negative 2x to the fourth. Because when I multiply like bases, I add my exponents, yes? Okay, plus negative 2x times 3x is negative 6x squared. Oops, I have too many things marked and I didn't notice that was a 2, so that would actually be a 3. Because I'm going to take 2 plus 1 would give me 3, minus 8x squared. Okay, and you can write this right here. If you want to write this as minus x squared, that is fine. That's the same answer. Okay, so now try that next one. I'm going to pause. You go. So you've had a chance to do B. So now we're going to multiply right here, and we're going to take negative 4x times 2x squared. That's a negative 8x cubed. Negative 4x times negative 3x is a positive 12x squared. And then negative 4x times 5 would be negative 20x. Okay, no problem there. It's just distributive property, but now it's got that added bonus of we get to deal with exponents too, so it's kind of cool. So now we're going to find the area of each rectangle. So what we're going to actually start off by doing is that we're going to break it down, and we're going to break it into each little rectangle. So if I wanted to find the area of this rectangle right through here, I would actually take 2x times 5x. That would give me 10x squared. Then I would find this area. That would be a 4 times a 5x. That would be 20x. And then I'd take 2x times 2, and this would be 4x. Then I'd take 4 times 2, so that would give me 8. Now, my only like terms would be right here, so I'd combine those. So I would have 10x squared plus 24x plus 8. Okay, so what we've just done is we have taken 2x plus 4 times 5x plus 2. We've actually multiplied those and found the area of this entire green one by multiplying 2x plus 4 and 5x plus 2. Okay, so this is one way that we can show it. And this is a lot of times, so this is just finding the area. Okay, so if you want to try B right now, I'm going to pause. I'm going to do it. You do it. Go. So when we found the area of the green part, we actually just broke it down into little rectangles and we multiplied. You can see that I circled the like terms and I combined those. Okay? Now we're going to multiply a binomial times a binomial. Okay? And we're going to distribute each term in the first binomial to each term in the second one. So what this is showing is that I'm going to take 2x times x minus 5. And then I'm going to take 4 times x minus 5. So I'm going to do both of those. And you can just distribute the 2 and everything. So this is a way you can write it out. I am not going to write it out this form. I'll show you how I will do it too. But I just wanted to show you what is happening. We're taking the 2x times x minus 5. And then we're taking the 4 times x minus 5. And that's what this is showing here. And it might be helpful just for your brain to see it that way. So now we have seen 2 other ways that we can multiply this. I'm going to show you the way I do it. I start off with one term and I multiply 5x times 2x, 10x squared, 5x times 1, and I get 5x. Then I do negative 4 times 2x, negative 8x, and negative 4 times 1, which is a negative 4. Combining like terms in the middle, I get a 10x squared minus 3x minus 4. So we've done the box method. We have done showing where I write it out in distributive property, and I'm going to show you all of those and what I'm talking about. But I want to show you this is the way my brain works and how I write it out. So again, I can do a box method where I can take 5x and negative 4. I put it into a box, and I'm going to multiply then 2x plus 1. So there's one option. You can multiply it that way. The other way that you can show it is that you can take 5x times 2x plus 1 plus, or minus actually, in this situation would be a minus 4 times 2x plus 1. So all I've done was break down that first one. I kept this together, and I'm going to do distributive property twice. So I have 1, 2, 3 methods. I would like you to pick the method that works best for you and try B. Go. So if you're doing it by box method, whoops, I just moved the 3, and now I just erased it. So if you're going to be doing the box method, you're going to take 3x times 2x, and then 3x times 4, and negative 5 times 2x, negative times 4. Okay, so that would have been a 6x squared, 12x, negative 10x, and a negative 20 to give you 6x squared plus 2x minus 20. The way I like to do it is I like to take the 3x times the 2x, 6x squared, 3x times 4, 12x. Then I take negative 5 times 2, which is negative 10x, negative 5 times 4, which is negative 20. Whoops, forgot my x. So again, I get 6x squared plus 2x minus 20. Same answer I got with box method. Now, I do want to point out one more thing with this. This is done so much that at one point somebody named how we do this, and I'm going to tell you about that. So, another way that people think of this is what's called FOIL. I like to think of it as distributing twice because it feeds right into the next thing we're going to be looking at. But you'll sometimes hear somebody say, hey, just FOIL it. And what that means is I'm going to take the first terms and multiply them. But I'm going to spell it right. First terms and multiply them. So here that would be 4x times 2x. Or here, let's do this one, 4x, 3x, and 2x, and that gives me 2x squared. So it's first and then outside terms. And what they mean by that is the 3x and the 4. Then it's the inside terms. So that's going to be the negative 5 and the 2, and then the last terms, negative 5 and 4. So I'm really not trying to confuse you, but I just want to prepare you for the future. And there are many ways I can do a box method. I can distribute twice. That's what I'm doing here. I could also refer to it as first, outside, inside, last, FOIL. So which is what I'm doing here. I take the first, then the outside, then the inside, and then the last ones. So this all means the same thing. Okay? So I'd like you to practice it one more time. So I'd like you to jump to page 144 in your book and do number 6 right now. So I'm going to pause it. You're going to do number 6 by box method, distributing twice, FOIL. All means this is going to give you the same answer. So go ahead and try number 6 right now. Go. So in try number 6, I'm going to do it the way I like the best. Hopefully you found a way you like best. So I'm going to take the first terms. So I'm going to distribute twice. So 2x times x is going to give me 2x squared. Then I'm going to take 2x and negative 4, which is negative 8x. I am then going to multiply the 6 times the x, so I get 6x. And 6 times negative 4 is negative 24. I then combine like terms, and I get 2x squared minus 2x minus 24. No matter which method you chose, that would be your answer. Good. I just wanted us to practice it one more time before we go on to the next thing. The next thing we're going to do is we're now going to multiply a binomial, 2 terms, binomial, times a trinomial. Okay, so if I want to do that, again, I can use box method. So I can put 3x and 4 right here, and then I'm going to put x squared, 2x, and negative 1 over here. And you can see you're just going to multiply and find all those little boxes. So this is one way of doing it, box method. Okay, and I wanted you to see that one. The way that you'll see that I do it is that I just, again, distribute twice. Okay, so I'm going to take 3x times each of the terms here. So 3x, and if you could see my finger, you'd see me, I'm going to be putting my finger at the 3x and multiplying times all of them because these loops get too much. So 3x times all of it, I get 3x cubed plus 6x squared minus 3x. Then I move my finger to the 4, and I go through and I multiply, so I'm going to take 4 times x squared. So I get plus 4x squared plus 8x and minus 4. Now we're going to combine like terms. 3x cubed does not have any. And again, write your answer in standard form, meaning highest exponent to lowest exponent. So I have 3x cubed plus 10x squared minus 3x, and 8x would be a plus 5x, and then minus 4. So you see you're doing the exact same thing. You can use the box method. You can distribute twice. Both are going to work. So I'm going to do one more with you. I'm going to do B, and these are in your book on page 143 if you're wondering where you're getting them. I'm going to start with B, then I'm going to have you try A. So I'm going to take negative 3x times everything. So I'm going to negative 3x times everything. And I get negative 6x to the 4th minus 9x cubed plus 12x squared. Now you can't see it right now, but I underline negative 3x because I'm just going to concentrate on that. My finger's there. Now I'm moving my finger to the 1, and I'm going to multiply 1 times everything. Then I'm going to combine like terms. Now you could see it could be very easy to make a mistake on this, so you want to be very careful and you want to show your work. So when I combine like terms, I start with the highest power, so negative 6x to the 4th, because I want my answer in descending order in standard form. Then I take negative 9x cubed and, oh, no, those are not like terms. There's not another cubed on there, is there? No, there's not. So my mistake. Those are not like terms. Don't combine them. So that's what I'm saying. Watch for details. Those are not like terms, so it's negative 9x squared, x cubed. Now I just have an x squared, so plus 2x squared. And I know the temptation is to like cross through it. Well, then it makes it harder for me as a teacher to go back and see where your mistakes are. So I'd appreciate it if you just kind of indicate, hey, I'm going to combine these as like terms. So then it can still be seen and you can go back and see what's going on. Okay, and that's all you can do. That's in simplest form. I'd like you to go try A. Go. So either you drew a box over here, and I'm just going to remind you of what the box method would look like. So I'd have a 2x here and a negative 5, and then I'd have a negative 3x squared and a 4x and a 7, and I would draw a box. So if you do box method, this is what's happening. I'm going to do distributive, so I'm going to take 2x times everything. So I have negative 6x cubed plus 8x squared minus 14x. Now I'm going to move my finger to the negative 5, so I have a positive 15x squared minus 20x plus 35. Now we combine like terms. So I have a negative 6x cubed, doesn't combine with anything. 8x squared and 15x squared. And that'd be 23x squared. Negative 14 and a negative 20 is negative 34x. And then plus 35. So that's how to multiply a binomial times a trinomial. And again, you would have gotten that same answer had you done the box. Now, if you do the box on this one, again, you're going to get negative 6x cubed, 15x squared, 8x squared, negative 20x, 14x, and negative 35. And you'll see that what happens is your like terms are going to be diagonals from each other. And I'd like you again to pick the method you like best. So this next thing you see in front of you is actually example 5. I'm not going to worry about it too much, but I want you to start to understand what it means if something is closed. Okay? So why is the operation of multiplication closed over the set of polynomials? For example, you found the product of two polynomials. Consider this example. When you multiply and you have to have whole number exponents, okay, the product will also be whole number exponents. So in order for something to be closed, it has to stay within the same set. So if I multiply things with whole number exponents, I'm going to get whole number exponents. When you multiply two binomials, the result is a sum or a difference of the terms. Each number is a real number coefficient multiplied by a variable raised to a whole number exponent. Each term is a monomial, so polynomials are closed under multiplication. I just wanted you to have that in your brain. It's something that will probably come up later on in high school math, and I just wanted to expose you to it now to show you what it means to be closed. And the operation of multiplication is a closed one. Okay, so again, why is it important that the product of two polynomials? So this is actually example number 5. The other thing I told you was not in your book. Why is it important that the product of two polynomials only have whole number exponents? Because we want it to remain closed. It has to be closed under multiplication. So we have to have whole number exponents. We can't have those fractional exponents. Okay, this is example number 6. A smartphone has a screen that has a width of x, and this is the screen, has a width of x and a height of 1.9 times the width. The outer dimensions of the phone are shown. Write an expression for the portion of the phone, and we just want an expression. We can't solve anything yet, but we want the portion of the phone that is not occupied by the screen. So what we have to do here is we have to understand that the width is x. This is x, and this is 1.9 times x. That is the inside part. That is the screen in through here, okay? So my screen is, and in order to find area, okay, so I'm finding area, so my screen is 1.9x times x, because that's the length times width, okay? Then I have my outer part, and I have, here is my width, and here is my length. So if I want to find the total phone, then that would be x plus 1, there's my width, times my height of 1.9x plus 3. Okay, so in other words, the width out here is 1 more than the width in here, and the width out here on the outside of the phone is 3 more. That's all they did. Okay, so they added that on. Now what they want us to find is what is the part of the phone occupied not occupied by the screen. So that means I have to take the phone minus the screen. So what I'm going to actually do is I would, if it were me personally, I would multiply these two things first. So what I'm saying is that I would multiply this right here. 1.9x times x is 1.9x squared. Okay? Then I would multiply this part, so that would be 1.9x squared plus 3x plus 1.9x plus 4. So my phone is 1.9x squared plus 4.9x plus 4. So I took my phone, combined my like terms. I'm going to take that and I'm going to subtract off the screen, which is 1.9x squared. Then I'm going to combine like terms from here, and remember when you subtract, cross the line and change the sign. Combining like terms is going to eliminate those. So I get 4.9x plus 4 is my expression that shows what the area of this phone is minus the screen. Okay, good. And this is a very common type of problem where they talk about the outside, okay, and the inside, but what they really want to know is what is this area here. Good. So this screen right here is just a summary of what we've been doing. I forgot to show you how to multiply vertically. It's not my favorite method, but there it is if it's something you like. So what you do is you take 3 times 2, and that gives you -6, 3 times x. Then you take x times 2, but you have to line up your like terms and x times x. And that is another way of doing it. I forgot to show you that. Feel free to use that if that's something you like. We are now on page 144, looking at number 3. I'm just skipping over 1 and 2. Mercedes states that when multiplying this, the product is this. What is Mercedes' errors? Whenever you're doing error analysis, they're asking you the error, then do the problem yourself. So take this right here and multiply. So that gives me 4x2. When I multiply, I add my exponents. So 8 times x to the 5th minus 12x cubed. So I've done the problem. Now I can compare as to what they did. Do you see what the mistake is? That's right. She multiplied the exponents. When I multiply like bases, I have to add the exponents. So that was her mistake, is that she multiplied the exponents. You don't want to multiply the exponents. You want to multiply the bases, which means that you would add the exponents. Now, jumping to number 5, we already did number 6, so if you would like to do number 5 right now, go. So when you distribute the negative 2x cubed times 3x squared, you'll notice, remember again, that you're going to add the exponents because you're multiplying like bases. Number 7, I'd like you to try that one, please, by whatever method, box method, distributing twice, which is also FOIL. You can multiply vertically. Go. So when you multiply, you get 3x squared plus 4x minus 6x minus 8, combine like terms. And you're going to get 3x squared minus 2x minus 8. Try number 8, go. Remember, you're going to multiply twice or draw the box. So you got 20x y cubed, 20y cubed, 15y squared, minus 5y. Then I took negative 2 times everything, and I got a negative 8y squared, negative 6y, and a positive 2. We're now going to combine like terms. So 20y cubed, 15x squared, and negative 8 is going to be 7y squared. Negative 5 and negative 6 is negative 11y plus 2. So on number 9, you're doing the same thing as number 8, but they just put the binomial in the back. That throws me off. You can still do it, but for me personally, I'm going to rewrite it to be 2x minus 3 times 3x squared plus 2x minus 5. Okay? That way, when I distribute, for me, it just makes it, then I only have to distribute twice if I put this one first. Okay? So feel free to rewrite it or not, but this is what we're multiplying. You can do it either way. I could have left it. I could have put it in a box. You get the point. Okay? So go. So I originally multiplied 2x times everything, and that is what you see in green. Then I multiplied negative 3 times everything, and that is what you see in blue. Now we combine like terms, 6x cubed minus 5x squared minus 16x plus 15. Great. One more. Find the area of the rectangle. This is a very typical type of problem that you're going to have to find the area of a rectangle. So how do I find area of a rectangle? Well, that's going to be length times width. So in this situation, here is my width and here is my length, or vice versa. It doesn't matter because you're going to multiply. So you're going to take 4x minus 2 times 2x plus 4. Remember, with perimeter, you add all the sides. With area, you multiply. So now you're going to distribute this, and you get 8x squared plus 16x minus 4x minus 8. So I get 8x squared plus 12x minus 8. And that is the area. We are now done with the notes, so hopefully this is very helpful. If you have questions, make sure you talk to your teachers, because if you have questions, you know where to find us. Thanks.